Number 11. The function f is defined by f of x equal to x squared plus 4ax plus a, for x being an element of a set of real numbers where a is a constant. The function g is such that its inverse is the cube root of 2x minus 4 for x being an element of a set of real numbers. Given that the range of f is f of x greater than or equal to minus 33, find the possible values of a, right? And for this, we're going to be using this expression for f of x, right? We know from the question that our f of x is x squared plus 4ax plus a, right? And for us to be able to deduce the range, we first need to express this in completed square form. And for that, we'll say x plus half of this, that will be 2a squared is half of the coefficient of x plus a, then we subtract this squared, this 2a squared, which is 4a squared, right? So this is the completed square form of f of x. And with this now, if we rewrite it to be a minus 4a squared plus x plus 2a squared, we see that for whatever value of x that we input here, we'll get a positive value of this, right? So in other words, we're adding this, the value that we get from x plus 2a squared to a minus 4a squared. And if we know that our range is greater than or equal to minus 33, if this a minus 4a squared is minus 33 and we're adding a positive number that we're getting from this, it means our f of x will always be greater than or equal to minus 33. Because if we get a 0 from here, it will be minus 33 plus 0. Then if we get anything else besides a 0, it will be greater than or equal to minus 33, right? So we're going to equate this to 33, right? So a minus 4a squared equals 33, right? And taking everything to the right hand side will be 4a squared minus a plus 33 equals 0. And to get a, we're going to use the quadratic formula. A equals 1 plus or minus 1 minus 4 ac, and our c is 33. Oops, supposed to be minus 33 here. Remember, we're saying a minus 4a squared equal to minus 33. So this is a minus right here, over 2 times 4, right? And if we punch this in our calculator, we get a equals 3, or a equals minus 2 and 3 over 4, right? And these are the two values of a, right? And that's it for the first part A. Moving on to part B, it's saying given instead that f g g, substituting 0 into the last g equals 96, find the value of a. So we work from inside going out, right? We first need to get g 0, right? But if we look at our equation, we are only given the inverse, right? But we know we can get g of x from its inverse. So we're going to try and get g of x first. So if the inverse is equal to the cube root of 2x minus 4, we're going to place x where there is y and y where there is x. Then we try and make the y the subject to get g of x. So this will be y, right? Now we're making this y the subject, so cube both sides. X to the power 3 plus 4 should be equal to 2y after this. Then if we divide both sides by 2, we get our y equals x to the power 3 plus 4 over 2. And this is the expression for g of x. X to the power 3 plus 4 over 2. Right? With this now, if we say g of 0, we are replacing x with 0. So it will be 0 plus 4 over 2. And that will be 2. So we now know that g of 0 here, it's 2. Now we're working with g of 2. g2, right? And with our expression for g of x, which is x cubed plus 4 over 2, if we sub in 2 for x, it will be 2 to the power 3 plus 4 over 2. That's 8 plus 4, 12 over 2, which gives us 6. So in other words, we're working with f6, right? This whole thing is giving us 6. So working with f6, meaning if we substitute 6 for x in the expression of f of x, it should be equal to 96 according to part 3, right? And our f of x is x squared plus 4ax plus a. X squared plus 4ax plus, was it a? Yes, see, right? So if we sub in 6, it will be 6 squared plus 4 times 6a plus a, and this should be equal to 96. So this would be 36 plus 24a plus a equals 96, right? 25a equals 96 minus 36, right? So 25a equals 60. So a will be 60 over 25 if we divide by 25 both sides, and a will be 60 over 25 be 2 and 2 over 5, right? And that will be the value for a.